We're diving into a cosmic mystery that's completely changing our understanding of the early universe. Imagine galaxies, the building blocks of everything we see today, forming shortly after the Big Bang. But then some of them just stop. They stop forming stars, become like ancient cosmic ghost towns. For years, we thought galaxies in the young universe were always busy nurseries, constantly building new stars. But the James Webb Space Telescope is showing us that some massive galaxies shut down incredibly quickly, a shocking billion years or less after the Big Bang. How is this possible, and what powerful forces could silence the galaxy so early in life? Stay with us as we explore this quintessent galaxies and the revolutionary discoveries the James Webb Space Telescope is making that are forcing scientists to rewrite the cosmic story. What do you think about this, John?
Yeah, this is cool. It's interesting. So what they did was they revealed that some galaxies stopped forming stars incredibly early, which is different than what they did. And they're calling them quiescent galaxies. And so they appear red due to their aging stars, but apparently they mysteriously shut down star formation far sooner than predicted. And so the new data suggests that the raw materials for stars was rapidly expelled by powerful forces within the galaxy. And this was likely linked to supermassive black holes or intense stellar activity. So this is challenging existing theories, which is great. The JWST I love the James Webb Space Telescope because it's really helping us hone in and challenge our understanding of the universe itself. So it was the infrared capabilities which confirmed the quiescent galaxies at S greater than 7, which is a regime previously inaccessible, which is super, super cool. So this is great because obviously we're learning and we're evolving and we're changing our fundamental understanding of the Big Bang and the universe.
Indeed, it's really cool. So they're talking about this Rubies-UDS QGZ7 galaxy. This a remarkable cosmic fossil existed just 700 million years after the Big Bang, making it the most distant massive quiet galaxy is what it means ever observed. What even more astonishing is that before shutting down, the galaxy has already formed an approximately 15 billion solar masses worth of stars, a mass comparable to our own Milky Way, but assembled in a fraction of the time. So so obviously it was expelling all this stuff, and then all of a sudden it stopped. And so this leads us to what's going on. And, I'm going to make this into, funny, I guess, but the supermassive black hole burped and knocked all the gas out of the galaxy.
It's crazy.
That's what they're saying. And, we're always thinking that everything is always sucked into a black hole and nothing can escape. But when supermassive black holes actively consume matter, they don't swallow everything that approaches them. The tremendous gravitational forces and extreme temperatures around these cosmic behemoths create what astronomers call an active galactic nuclei, AGN, regions where matter is superheated and partially ejected in powerful jets and winds rather than falling completely into the black hole. These energetic outflows can reach velocity of thousands of kilometers per second, easily exceeding the escape velocity of the host galaxy. When these powerful jets and winds interact with the surrounding gas in the galaxy, they can effectively push the gas outward, driving the rapid gas expulsion observed by the James Webb Space Telescope.
Yeah, this is cool. And there's a couple geeky things that I'd like to point out here that I learned. So, and I guess I got to fact check this, but this was Neil deGrasse Tyson that said this. There are more stars in the sky than there are grains of sand on the earth, which blows my mind. Yeah, and also we covered, and about the black holes too. I think we covered, it was some sort of radiation that they were calling it that escaped from the black hole, right? There was something. Anyways, and the last thing is that, as we're looking at this, guys, like essentially observing this stuff, we're looking back into time. And go ahead.
No, there is. We did this. Sorry, it took me a while. Like we talked about a subject we talked about 100 episodes ago, and
Yeah.
black holes glowed. So go back, look, read, watch that episode about black holes glowing, and we'll talk about the types of radiation and stuff that escape the black hole gravity. And obviously, these things escape the black hole gravity too. So I just wanted to comment on that.
No. Yeah. But like any time that we're looking at anything like this, guys, we're essentially looking back into time. So if you think about it, light can only travel at light speed. That's as fast as it can travel, or whatever. We can get into the nuances of some new findings. But so anything that we're seeing it happen billions of years ago or millions of years ago, anything that we're observing now, which is a cool concept to think about.
Yeah, and the universe, everything we're observing is challenging our theoretical models, which is great because we're learning more and more and more. And, we're seeing what happened billions of years ago, which is amazing because of the James Webb. So the discrepancy between observations and theory isn't just an academic concern. It points to fundamental gaps in our understanding of physical process that governed galaxies' evolution in the early universes. So some possibilities include black hole feedback mechanisms may be significantly more powerful than current models predict. The coupling between black hole energy output and interstellar gas may be more efficient. Alternative quenching mechanisms. Quenching is when, the galaxies die down or slow down or stop creating. So alternative quenching mechanism might be at work that aren't adequately represented in simulations, and the initial conditions of the early universe might need to be reconsidered. And we talked about this a couple of weeks ago when dark matter existed before the Big Bang, which challenges a lot of our thoughts on how the universe came to be. So a lot of this is happening. So I'm really interested in these challenges open exciting new avenues for future research using the JWST and other advanced observatories. Key questions astronomers are now pursuing include gas recycling potential. Can the expelled gas eventually fall back into these quiet galaxies, potentially reigniting star formation, or does it escape permanently into intergalactic medium? Prevalence of early quietness. How common are these quiet galaxies in early universes? Is Ruby UD6 QGZ7 an anomaly or represent a significant population? Black hole growth patterns. How do supermassive black holes grow in these early quiet galaxies? Grow and evolve over time? Do they continue to influence their host galaxies even after the star formation has ceased? And galaxy cluster environments. Do early quiet galaxies prefer particular cosmic environments such as protoclusters or cosmic filaments? So, there's a lot of stuff to look at here. There's a lot of stuff for scientists to reevaluate and challenge known theories. I'm really interested in finding out what they discover.
Yeah.
So we can expect further revelations about quiet galaxies, gas flows, and supermassive black holes feedback to refine our understanding of early galaxies' evolutions. These discoveries not only satisfy our cosmic curiosity, but also remind us that the most fundamental aspects of our universe story may contain surprise chapters yet to read. So what do you think about this? Is this cool? Does this matter? Does this allow us to have a little bit more thoughts on maybe we can inject these gases into dead galaxies and reignite them to create possible new life in the future? We'd love to hear your feedback. Leave us feedback in the comments below.
Well, so there'll be a Startup Investor Drinks in June. I've got my head down for my shred clients and grants and things like that. But if you do want some help, feel free to reach out to me on LinkedIn, John Irwin. But if they need help with coaching for their business, anything related to helping them with their business, how do they find you, Craig?
Well, Startup Investor Drinks is June 26th. So mark your calendars, go to Startup Investor Drinks TO and get your tickets. We will be having a automation event during Tech Week as well. I just haven't booked it yet, so look forward to that. And if people want coaching, if you're stuck, you can go to startupcoach.ca or click on the Startup Coach button, book a discovery call. I'll have a 15-20-minute call, and we'll see if it makes sense to work together, if we can help each other, you like our style, that kind of stuff. Feel free to book that free call anytime. And for everything else, check it out at torontostarts.com. And if you're looking to automate your business, take it to the next level, stop doing repetitive tasks, Check out flowgrammer.ca for all your automation resources. And if people looking for non-dilutive funding, John, where do they go?
Come find me on LinkedIn, John Irwin. Yeah, any kind of non-dilutive funding. I guess in June right now, we'll have maybe FedDev open right now. So
awesome. And just as we said that, I got a new TidyCal booking right now for Startup Coach Meeting. Thanks, somebody, for watching and booking that. We'll see you all next time on Silicon Scoop. Thanks for listening.